The question I have is, could you tell us about the origin and types of soil and rock? Let's start with the question of where the soil came from. Well, soil came from rock through a process called weathering. So, a good place to start for answering these questions is to see where the rock came from. The origin of rock depends on the type of rock. There are three types: igneous, sedimentary, and metamorphic. Let's take the first one, igneous rock. Igneous rock is formed by solidification of magma. Here's a list of examples of igneous rock: granite, gabbro, basalt, sienite, rhyolite, diabase, diorite, and andesite. I'm sure you have heard of some of these, in particular granite. A lot of people have granite countertops and granite tiles in their kitchen, right? Here's a picture of a piece of granite. What about sedimentary rock? Well, sedimentary rock is formed by compaction of sediments, plant materials, and animals by overburden pressure and heat. And here are some examples of sedimentary rock: sandstone, shale, and there are a couple of different kinds of shales: conglomerate, limestone, rock salt, dolomite, gypsum, chalk, and breccia. I also indicated the chemical composition of some of these sedimentary rocks. For example, limestone is calcium carbonate, rock salt is sodium chloride, and so on. Here's a picture of a piece of limestone. Now a little bit about metamorphic rock. So this rock is formed by metamorphism of igneous and sedimentary rocks deep within the Earth's crust by overburden pressure and heat. These are some examples of metamorphic rock. Again, some familiar ones like marble and slate. Basically, limestone turns into marble, sandstone turns into quartzite, shale turns into slate or phyllite or schist. Here's a picture of a phyllite. Earlier we said soil came from rock by a process called weathering, right? There are two types of weathering: mechanical weathering and chemical weathering. Here's a little bit about mechanical weathering. When the temperature goes up and down, the rock repeatedly expands and contracts, experiencing a degradation. A similar effect happens when the water in cracks experiences freezing and thawing. Agents such as running water, ocean waves, and wind cause gradual erosion. Glacier ice is another agent that can lead to mechanical weathering. An important point to note here is that, contrary to chemical weathering, the mechanical weathering does not alter the mineral type, and therefore the soil produced by this method will have the same mineral as in the parent rock. Here's a picture showing erosion by ocean waves and wind. In chemical weathering, however, you have chemical reactions taking place, and these chemical reactions alter the original minerals, and therefore the minerals in the resulting soil are not going to be the same as the minerals in the original parent rock. The chemical weathering is one of the ways in which clay minerals have been produced. The water reacts with carbon dioxide in the air to form carbonic acid, which ionizes into H plus and HCO3. The hydrogen ion and water then reacts with orthoclase, which is a mineral in granite, leading to these products, and one of which is kaolinite, a clay mineral. Now we know soil came from rock through weathering processes. I know the coverage here is kind of superficial. Had this been a geology course, the details would have been covered a lot more extensively. But this is good enough from a geotechnical engineering point of view. So at this point, let me talk a little bit about soil types. The soil is divided into two categories. Those with the particle size greater than 0.075 millimeter belong to this group called coarse grain soil. So boulder, cobble, gravel, and sand belong in this group here. The particle size decreases as you go down in this list here. In terms of shape, some of them are kind of smooth and round like this, and the others are angular like this one right here. The second category is called the fine-grained soil. So those soil with particle size less than 0.075 millimeter belong in this group. Basically, silt and clay belong in this group. There are several types of clay minerals, but these are the most common types of clay minerals: kaolinite, illite, and montmorillonite. Again, the particle size decreases as you go down in this list. So clays have smaller particle size than silts, and within clay, montmorillonite has a smaller particle size than kaolinite. And they have a platy shape. Here's a picture of a sand, and if you zoom in, you're going to see something like this. Here's a picture of kaolinite. The clay particles are so small that you have to use something like a scanning electron microscope to see the details at the particle level. You can get an idea of the shape and size of kaolinite particles from this picture right here. You can clearly see they are platy over here. They are not round by any means, but this particle has a width of roughly 2 micron. Here's a scanning electron micrograph of a sample of montmorillonite. The particle size is a bit difficult to see from this picture. They curl up because they are so thin. So this is a grouping of soil in a broader sense on the basis of particle size.